Hi friends, see today we'll be starting our last topic in our first year intermediate, that is thermodynamics. Okay, so in thermodynamics, first of all let us see what are the main things to discuss in this chapter. Okay, in thermodynamics, what is the definition of thermodynamics? Already in dynamics we know the definition. Under the action of external forces, the mathematical and physical study of the bodies is called as dynamics. Thermodynamics and thermo heat, under the application of heat or under the supply of heat, okay, the work done by the matter. Okay, so here work done by what? Will be generally taking gases. Okay, so therefore thermodynamics means under the process of heat giving externally how the matter undergoes work, that is called as thermodynamics. Whereas in dynamics, under the external forces, the mathematical and physical study of the bodies is called as dynamics. Okay, now in thermodynamics, let us see first thing, that is what is zeroth law. Let us study about what is zeroth law. Zeroth law of thermodynamics. Right. So, today we will be dealing about in our thermodynamics chapter, that is, see, just now I am discussing about the last chapter, that is in first year intermediate, thermodynamics. So, in thermodynamics we will be discussing about, first of all, zeroth law in thermodynamics. So, what is zeroth law? See, zeroth law in thermodynamics. Zeroth law in thermodynamics is nothing but, for example, you take three bodies, namely A, B and C. Take three bodies, okay, namely A, B and C. For example, first I will take A and C and join together. First I will take A and C, I will join together. Now what happens after some time, both will have, for example, this is a different temperature, T1. This may be a different temperature, T2. This may be a different temperature, T3 degrees centigrade. When both are joined A and C, after some time, both will have same temperature. That means they will be attaining thermal equilibrium. Ante ardham enti? Thermal equilibrium ante ardham enti? The temperature difference is zero. That means A and C will have same temperature. What does it mean? A and C will have same temperature. Okay. So after some time, both will be coming to equilibrium temperature. And A, C rendu pakkan pettinappudu, of course, which is having higher temperature, from that it will emit the radiation. And finally, both will attain equilibrium state. That is called as thermal equilibrium. Now what I will do? I will take away C separately. Now I will join with B. I will take away C and now I will join with B. Now what happens after some time? Again B and C will be in thermal equilibrium. అంటే ఈ రెండింటి యొక్క టెంపరేచర్ కూడా మళ్ళీ సేమ్గా ఉంటాయి. సో ఏంటి దాని అర్థం ఏంటి? వాట్ డస్ ఇట్ మీన్? In other words, A, B, comma C, all the three will be in same temperature. That means A, B, C are in thermal equilibrium. అంటే అర్థం ఏంటంటే, if A and B are in thermal equilibrium separately with the third body C, then A, B, C all will have same temperature. All are in thermal equilibrium. That means the temperature difference is zero between them. That is the meaning of thermal equilibrium. So in thermodynamics chapter, this is the beginning, that is zeroth law. The zeroth law is the beginning in thermodynamics. Very, very important one. It may be coming for 2 marks question in IPE. Clear? Right. Please note down. Now, after learning about the zeroth law in thermodynamics, now let us go still further in this one. Okay. The main thing is in this one we'll be studying is, okay, that is degree of freedom. Okay na? అసలు డిగ్రీ ఆఫ్ ఫ్రీడమ్ అంటే ఏంటి? ఇందులో మనం థర్మోడైనమిక్స్లో చాలా ఇంపార్టెంట్ టాపిక్ ఇది, డిగ్రీ ఆఫ్ ఫ్రీడమ్. డిఓఎఫ్ అంటారు ఏంటి? డిఓఎఫ్. దిస్ ఆల్సో కాల్డ్ యాజ్ డిగ్రీ ఆఫ్ ఫ్రీడమ్. ఏంటి డిగ్రీ ఆఫ్ ఫ్రీడమ్? చూడండి. See, generally we have different type of gases like monoatomic gases, like noble gases, ఎలాంటివి? హీలియం, నియాన్, ఆర్గాన్, ఓకే, క్రిప్టాన్, జెనాన్, రెడాన్. 8th గ్రూప్ ఎలిమెంట్ పీరియాడిక్ టేబుల్లో. సో ఇవన్నీ నోబుల్ గ్యాసెస్. హీలియం, నియాన్, ఆర్గాన్, క్రిప్టాన్, జెనాన్, రెడాన్. ఇవన్నీ దీస్ ఆల్ కమ్స్ అండర్ మోనో అటామిక్ గ్యాసెస్. మోనో అంటే ఏంటి? సింగిల్ యాటమ్. మోనో మీన్స్ సింగిల్ యాటమ్. And you know the radius is very less, around 0.529 angstroms. Around 0.529 angstrom. What is 1 angstrom? 10 power minus 10 centimeters. Okay? 10 power minus 10, 10 power minus 8 centimeters or 10 power minus 10 meters. 1 angstrom and ఎంత అండి? 10 power minus 8. Okay? Or 10 power minus 10 meters. 1 angstrom. Because generally because comes under atom, atomic size is very less, so that is why it is measured in angstrom. Okay? 1 angstrom is 10 power minus 8 centimeters or 10 power minus 10. Very less. 10 power minus 8 cm, or you can convert into meters as 10 power minus 10 meters. So radius is very less. Now we observe the motion of this one. So ఈ atom ఎలా వెళ్ళొచ్చు? It can go in x direction, it can go in y direction, and it can go in z direction. Translation motion, linear motion, straight గా x వైపు వెళ్ళొచ్చు, y వైపు వెళ్ళొచ్చు, z వైపు వెళ్ళొచ్చు. సో x వైపు వెళ్తున్నప్పుడు what is the kinetic energy? half m vx square. In y direction, what is the energy? half m vy square. In z direction, half m vz square. So it is ready to move freely without any discomfort in 3 directions. Translation motion. Okay? Translation motion, it can move freely either in x direction, y direction or z direction. Okay? Now coming to vibration and rotation అవుతుంది. For example, atom rotate అవుతున్నప్పుడు చూడండి, x direction, y direction, z direction. When it is trying to rotate in x direction or y direction, x direction అంటే ఇది, y direction, z direction. So when it is trying to rotate in x direction or y direction, what happened? It is rotating about the axis. So radius ఎంత? Radius అనేది చాలా చిన్నది, that is 0.529 angstroms. 1 angstrom is 10 power minus 10 meters. So అంత చిన్న radius లో what is the rotational kinetic energy? What is rotation kinetic energy? Half I omega square. What is I here? Moment of inertia. Mass into square of the distance. Mass into square. So square of 10 power minus 10. 10 power minus 20. So అంత తక్కువ వాల్యూ కాబట్టి kinetic energy rotational is neglected. Therefore, for monoatomic gases like noble gases, helium, neon, argon, krypton, xenon and radon, the rotational kinetic energy is neglected. Therefore, for monoatomic gases, the degree of freedom, generally it is written with F, is taken as 3 only. X, the only translation motion తీసుకుంటాం. X direction, Y direction, Z direction. Along X, rotational లో radius బాగా చిన్నది కాబట్టి it is neglected because the radius is small, so the rotation kinetic half I omega square, moment of inertia is very less, so it is considered as 0. So therefore, for monoatomic gases, F value, degree of freedom is taken as 3 only. Clear? Right. Now let us go for diatomic gases. Let us go for the next one, diatomic gases. చూడండి diatomic gases అంటే ఏంటి చూడండి ఒకసారి. ఫర్ ఎగ్జాంపుల్ diatomic gases. పేర్లు ఉన్న diatomic, ఫర్ ఎగ్జాంపుల్ నైట్రోజన్, ఓకే, hydrogen, okay, all these you can take diatomic. Nitrogen, okay, you can even take hydrogen gas, nitrogen gas. ఇంకా ఉన్న ఎగ్జాంపుల్స్ అవి కూడా మీరు నోట్ చేసుకోవచ్చు if you want in diatomic gases, okay, and those are nothing but sometimes CO2, okay, CO2, yes, O2 also you can take, oxygen molecule, okay, nitrogen molecule. Why I am taking molecule here? It is not single atom here. ఇందాక మనం మోనోఅటామిక్లో ఒక ఆటమ్ సింగిల్ తీసుకున్నాం. నౌ ఇట్ ఈస్ అ మాలిక్యూల్. నైట్రోజన్, హైడ్రోజన్, ఆక్సిజన్, ఓకే, నైట్రోజన్, ఆక్సిజన్ అండ్ హైడ్రోజన్. ఫర్ ఎగ్జాంపుల్ if you take these molecules, if you observe the phenomenon here, for example you take oxygen. If you take oxygen, okay, you can observe this is the molecule of oxygen. It is x direction, y direction, z direction. So in diatomic gases లో కూడా హైడ్రోజన్ కానీ ఆక్సిజన్ కానీ నైట్రోజన్ కానీ మాలిక్యూల్స్ x డైరెక్షన్లో తిరగవచ్చు ఫ్రీగా, y డైరెక్షన్లో వెళ్ళొచ్చు, ఓకే, అండ్ ఆల్సో z డైరెక్షన్లో, ఏది ట్రాన్స్లేషన్ మోషన్లో. బట్ కమింగ్ అండర్ రొటేషనల్ మోషన్, రొటేట్ అవుతున్నప్పుడు జాగ్రత్త చూడండి, ఎక్స్ డైరెక్షన్లో వచ్చినప్పుడు వై డైరెక్షన్ మళ్ళీ తిరుగుతుంది, వై డైరెక్షన్, ఎక్స్ డైరెక్షన్ ఏంటి అగైన్ లైక్ దిస్. ఇప్పుడు మీరు అబ్జర్వ్ చేస్తే కొంత డిస్టెన్స్ ఉంది, ఓకేనా, ఇందాక డిస్టెన్స్ లేదు. ఆర్ యు అబ్జర్వ్ ద పాయింట్ హియర్? సో కొంత డిస్టెన్స్ అంటే వెన్ ఇట్ ఈస్ రొటేటింగ్, సి ఫర్ ఎగ్జాంపుల్ దిస్ ఈస్ మాలిక్యూల్, ఓకే, ఎక్స్ డైరెక్షన్ అంటే ఎలాగా, ఇది ఎక్స్ డైరెక్షన్, ఇది వై డైరెక్షన్, ఇది జెడ్ డైరెక్షన్. సో ఇట్ కెన్ రొటేట్ లైక్ దిస్, ఇట్ కెన్ రొటేట్ లైక్ దిస్, బట్ వెన్ ఇట్ ఈస్ రొటేటింగ్ లైక్ దిస్, చూడండి ఒకసారి చూడండి, దిస్ ఈజ్ వై డైరెక్షన్, దిస్ ఈజ్ వై డైరెక్షన్, ఓకే, అండ్ దిస్ యూ కెన్ టేక్, లేదా యూ కెన్ టేక్ దిస్ వై డైరెక్షన్, దిస్ ఈజ్ జెడ్ డైరెక్షన్. But when it is taking x direction, what happened? Along the axis of rotation again, it is coming under axis of rotation. Axis of rotation లో rotational kinetic energy మళ్ళీ 0 అయిపోతుంది. అంటే ట్రాన్స్లేషన్ మోషన్లో 3, y ప్లస్ z డైరెక్షన్లో 2, మొత్తం ఎన్ని 5. సో అలాంగ్ x డైరెక్షన్ అది మళ్ళీ 0 అయిపోతుంది, బికాస్ along the axis of rotation moment of inertia is 0. So therefore, for diatomic gases like nitrogen molecule, hydrogen or oxygen, you can take it as 5 degree of freedom. And lastly, coming to triatomic molecules or polyatomic molecules. Adotha meku last one is triatomic or polyatomic. Monoatomic gases, diatomic gases, okay, అలాగే ట్రైఅటామిక్ ఆర్ పాలిఅటామిక్ గ్యాసెస్. పాలిఅటామిక్ గ్యాసెస్లో మీకు ఫర్ ఎగ్జాంపుల్ యూ కెన్ టేక్ SO2, CH4, NH3. CH4 అంటే మీ కెమికల్ ఐ థింక్ మిథేన్, NH3, ఓకే, అలాగే SO2 సల్ఫర్ డైఆక్సైడ్. సల్ఫర్ డైఆక్సైడ్ ఫర్ ఎగ్జాంపుల్ మనం తీసుకుందాం. సల్ఫర్ డైఆక్సైడ్ తీసుకుంటే అయితే దీని యొక్క స్ట్రక్చర్ ఈ విధంగా ఉంటుంది చూడండి. Sulfur dioxide molecule gas, sulfur dioxide gas తీసుకున్నట్టయితే the structure will be in this fashion. Now if you observe the triatomic gas or polyatomic gas like sulfur dioxide or CH4 or NH3 gas. So here you can observe x direction, y direction, z direction. So it can go rotate like this, go like this, or also it can rotate like this. So 3 direction, translation 3, and also rotation also. You can see that bond is like this, so it can rotate like this, It can rotate like this in all directions. So 3 plus 3, total is 6. So triatomic gases low, polyatomic gases like SO2, CH4, NH3, 3 plus 3, 6. So degree of freedom, you can take a normal condition, 3, 5, 6 for mono, diatomic, polyatomic gases. Normal condition. Suppose in the examination if they are asking for high temperature లేదా high vibration mode అడిగినప్పుడు దీనికి 2 కలిపేయండి, అప్పుడు 5, 7, 8. But this is rare case. Suppose if he specifies వాడు చెప్తే మాత్రం in the examination if he tells you high vibration mode, then only you add 2. Otherwise in normal condition degree of freedom for monoatomic gas is 3, diatomic gas like nitrogen, hydrogen, other things 5, polyatomic like sulfur dioxide, CH3 and NH3, you can take it as 6 only. Clear? And it is indicated with the letter F. Clear? So please note down, very very important in the examination they are asking regarding degree of freedom. Now let us go to the next one. After learning about the degree of freedom, okay, now let us see what is meant by internal energy. Okay, na? What is meant by internal energy? Okay, what is internal energy? Internal energy of any system. How can you define internal energy of any system? For example, take water. See, water under normal condition it is very cool. 0 degree centigrade liquid or 0 degree centigrade ice form. But when you heat the water, after boiling point, what happened? It is converted into steam. So this steam is used to generate electricity. So where from this energy has come for water? That is what internal energy. ఎక్కడి నుంచి వచ్చింది దీని శక్తి? అంతకుముందు వాటర్ మనం చల్లగా ఉంది, 0 degrees in liquid and ice form. But when you heat to boiling point, it is converted into vapor. When that water falls on the skin, it burns. So it is having a huge energy. So that is called as internal energy. Though it does not possess apparent mechanical energy, but still it has the capacity to do work. That is called as internal energy of the system. Internal energy అంటే though it does not have any apparent mechanical energy, but still it has the capacity to do work. That is called as internal energy of the system. And it is generally indicated with du. Because later on as the class progresses, we will deal about first law of thermodynamics, that is dq is equal to du plus dw. In that we will be studying detailedly what is du, what is dq and what is dw. But for instance now, internal energy means what? It is inside and not external it is. Though it does not have any apparent mechanical energy, it still has the, it can possess, it can do the work and it has the capacity to do work. That is called as internal energy. As the example of water, initial condition and after boiling to 100 degrees centigrade. Okay. Now let us go to the next thing, kinetic energy. Okay. Let us see what is meant by kinetic energy. Some formulas I will be giving for you because these are coming in the examination. Kinetic energy of the gas molecule. Okay. Try to write down some formulas. Kinetic energy of the gas molecule, Ke. That is kinetic energy of the gas molecule. So generally kinetic energy of one molecule and 1 mole, we have some formulas. See, for kinetic energy of one molecule is given by, okay, F by 2 into kT. F by 2 into kT. F is degree of freedom, monoatomic 3 normal condition, dia 5, polyatomic 6. K, Boltzmann constant. K is equal to Boltzmann's constant. And you know relationals R is equal to K into N, లేదా R by N is equal to K, where R is universal gas constant 8.314 joule mole inverse Kelvin inverse, N is also, it's also called Avogadro number. N is Avogadro number here. So R is equal to K into R by N is equal to K. You can substitute here. So this is what formula for kinetic energy for one molecule. In the same fashion, if they ask for 1 mole, kinetic energy for 1 mole, then you can take it as, okay, in the place of kT, I'll write it as F by 2 RT. Again, F is degree of freedom, R gas constant, because already we have converted from here, you can see R is equal to Kn, or R by N is equal to K. R by N is equal to K. ఈ K బదులు మనం R by N. R is nothing but what? Avogadro number. Okay? So, ఒక మోల్కి kinetic energy of the gas ఏంటి? F by 2 into RT. ఒక molecule అయితే F by 2 KT. Okay? Please note down, these formulas are very, very important. For 1 mole it is F by 2. Okay? F by 2 into RT. For 1 molecule it is F by 2 KT. Okay na? Now let us see further. Right. For example, consider ideal gas. Consider ideal gas. మీకు అందరికీ తెలుసు కదా, ఐడియల్ అండ్ మీన్స్ ఇట్ ఈస్ నథింగ్ బట్ ఇమాజినరీ గ్యాస్. ఐడియల్ అనేది వాడామంటే ఎక్కడైనా ఐడియల్ ఫ్లూయిడ్ కానీ ఐడియల్ గా ఇట్ ఈస్ నాట్ ఎగ్జిస్టింగ్ రియల్లీ, ఇట్ ఈస్ ఇమాజినరీ. ఫర్ ద calculation purpose will take. So for ideal gas, generally what will take is, okay, the U, internal energy, that is equal to kinetic energy. Okay, kinetic energy is taken as F by 2 kT. F by 2 kT. Okay, if n number of moles are there, then K is equal to n into F by 2 kT. N is number of moles, mass of the gas by gram molecular weight, grams. Okay, mass of the gas in grams by gram molecular weight. F degree of freedom, K Boltzmann constant, and T is absolute temperature. For ideal gas, you can take the equation as kinetic energy is equal to F by 2 kT, and if n moles are there, n into F by 2 kT. Okay, and this is also called as change in internal energy, delta U. Okay, this is also called as delta U, change in the internal energy, change in the internal energy, n into F by 2 kT. Okay, please note down. Clear, all of you? Now let us go still further. We will try to do a small numerical. Okay, calculate kinetic energy of 1.6 grams. 1.6 grams of O2 molecule. A small numerical, please note down. Calculate kinetic energy of 1.6 grams of O2 oxygen molecule. Okay, so this is the question. How to solve such type of problems in the examination? They give regularly such type of problems. So ipude meeku formula ichcharu kada, what is kinetic energy? Kinetic energy is given by what? N into F by 2. Okay, N into F by 2. Just now given the formula now. So in that formula you can apply N into F by 2 into RT. N into F by 2 into RT. This is the kinetic energy formula. So N is number of moles, degree of freedom F, R gas constant 8.314 joule mole per Kelvin. Okay, joules per mole Kelvin. T absolute temperature. So if you apply the things here, you can get the value. Okay, so ఎలా చేస్తే ఇప్పుడు మనకి ఇక్కడ ఏమి ఇచ్చాడు? 1.6 grams ఇచ్చాడు of O2 molecule. How to get number of moles? So N I can get as small m by capital M. What is small m? Mass of the gas in grams by gram molecular weight. So mass of the gas ఎంత ఇచ్చాడు 1.6 grams. 1.6 grams by what is gram molecular weight? Oxygen and 816. So mass number 16 2 molecule 16 to the 32. So 32 grams. Gram cancel, point, take 0 down, 16 ones are 16 20s are. So how many moles are there? N is equal to 1 by 20. Put it here. So kinetic energy is equal to 1 by 20 into degree of freedom. Oxygen belongs to what? Diatomic gas. So degree of freedom is 5. Normal condition. 5 by 2 into R. You can put the value there, R only, T only, because the values are not given. 5 ones are, 5 fours are. So what is the answer? RT by 4 twos are 8. So this is the kinetic energy. RT by 8. Okay? So like this you have to solve the numericals. Please note down. Okay? Let us go to the next one. Now, already in before chapter we have discussed some points regarding specific heat capacity. Okay? In heat transfer we discussed about specific heat capacity. Okay? What is specific heat, etc. Now here we will discuss about molar specific heat. Molar specific heat. Okay? Already specific heat capacity ఏంటి ముందు క్లాస్లో మనం డిస్కస్ చేసాం. dq by m into dt is equal to s లేదా dq is equal to m s dt. This is specific heat capacity of the body. But here we will be discussing about molar specific heat. Molar specific heat అంటే ఏంటి? Constant volume, constant pressure. We'll discuss about these two. Specific heat at constant volume, molar specific heat. అలాగే molar specific heat at constant pressure. So ఇవి ఎలా రాస్తాం ఇది మనం? Same thing. Okay? Is equal to mass బదులు n. ఓకేనా? mass బదులు n. What is CV here? Molar specific heat at constant volume. Molar specific heat at constant pressure. అదవుతుందా? సో n ఇంటూ సివి ఇంటూ డిటి లేదా డెల్టా టీ. అలాగే హౌ టు రైట్ సిపి? n ఇంటూ సిపి ఇంటూ డిటి ఆర్ డెల్టా టీ. అదవుతుంది మీకు? దిస్ ఈస్ కాల్డ్ as వాట్? మోలార్ స్పెసిఫిక్ హీట్ at constant volume, మోలార్ స్పెసిఫిక్ హీట్ at constant pressure. స్పెసిఫిక్ హీట్ ఆఫ్ ద గ్యాస్ అండి. సిపి సివి అంటే molar specific heat of the gas at constant pressure and molar specific heat at constant volume. Because already you have studied about heat capacity formula. M ఇది normal mass, ఇది mass into specific heat into temperature difference. So molar వచ్చినప్పుడు n into cv into dt, and this one I can write it in degree of freedom form also. And what are the units for this one? The units ఏంటి? Calorie per gram degree centigrade or joule per kg degree Kelvin. Okay, so here ఏమవుతుంది? ఇక్కడ యూనిట్స్ ఇక్కడ యూనిట్ చెప్పగలరా? సేమ్ థింగ్, జౌల్ పై మోల్ డిగ్రీ కెల్విన్. ఓకేనా? సో ఇక్కడ ఏంటంటే మాస్ బదులు గ్రామ్స్ బదులు మోల్ వస్తాయి. జౌల్ బై మోల్ డిగ్రీ కెల్విన్. ఇక్కడ కూడా అంతే, జౌల్ బై మోల్ డిగ్రీ కెల్విన్. ఇక్కడ ఏంటి? మోల్ బదులు మాస్ వస్తుంది ఇక్కడ, కిలోగ్రామ్. రిమైనింగ్ ఆల్ ఆర్ సేమ్. సో సివి ఐ కెన్ ఆల్సో రైట్ ఇట్ ఇన్ దిస్ ఫార్మ్. ప్లీజ్ సి, n into what is CV in terms of degree of freedom? F by 2 into R. In terms of degree of freedom, F is degree of freedom, R is gas constant. So I can write like this. The same way for Cp. How I can write? N into Cp F by 2 plus 1 into R dt. Okay? So Cp at constant pressure in terms of degree of freedom, I can write the value like this. Okay? That is nothing but Cp by the right, you know. F by 2 plus 1 into R. Okay, na? Clear? So this is what specific heat of the gas at constant volume and constant pressure. Clear? Please note down. A small correction I will give, please. Small correction, please. Sorry. This one I can add as dqv, please. Please, sorry, here small correction. dqp. Okay, small correction I have to do. Please correct this one because ఇక్కడ ఏంటంటే క్వాంటమ్ ఆఫ్ హీట్ కదా. ఓకే, సో dq by గా చూసుకోండి ఒకసారి. ఇది ఎలా వస్తుంది ఫార్ములా అగైన్? ఇది కాన్స్టెంట్ వాల్యూమ్ కదా, సో dqv by n dt is equal to cv. అలాగే ఇది కూడా ఏంటి? dqp by n dt is equal to cp. So please correct that one. I have written cv here instead of dq because it is a heat kada, quantum of heat. So dqv at constant volume by, so units ఏమవుతుంది అప్పుడు సరిపోతుంది కదా, జౌల్ పర్ మోల్ డిగ్రీ కెల్విన్, SI యూనిట్. ఇక్కడ కూడా జౌల్ పర్ మోల్ డిగ్రీ కెల్విన్. Now this is the correct form, please. Molar specific heat at constant volume, constant pressure. And these we can change in the terms of degree of freedom. Cv ki F by 2 into R రాసుకోవచ్చు, Cp ki F by 2 plus 1 into R రాసుకోవచ్చు. Clear? Please note down. Now let us go still further in this. Written? Now let us find a relation. Let us find a relation for Cp and Cv. Cp ki Cv ki relation ఏముందని ఫైండ్ చేద్దాం. Relation between Cp and Cv. Specific heat of the gas at constant pressure, constant volume. ఒకసారి దీన్ని చూడండి. ఇది n మోల్స్కి ఈక్వేషను. ఈ రెండు ఈక్వేషన్ తీసుకుందాం మనం. Cp ఏంటి ఫార్ములా ఇన్ టర్మ్స్ ఆఫ్ డిగ్రీ ఆఫ్ ఫ్రీడమ్? F by 2 plus 1 into R. అలాగే ఇవి క్యాన్సిల్ అయిపోతాయి కదా ఒకవేళ తీసుకుంటే ఈక్వల్ చేస్తే. అలాగే Cv I can write as F by 2 into R. Okay? Now I will try to write a small relation between these two. అదేంటో చూడండి. Suppose if I subtract from this one Cp minus Cv, what I will get here? F by 2 into R plus R minus F by 2R. So a plus F by 2 minus cancels, finally into R. So Cp minus Cv is equal to R, or Cp is equal to R plus Cv. That means Cp is always greater than Cv. From this it is observed that Cv plus, that means Cp is greater than Cv. And for all gases, Cp minus Cv is equal to R. For all gases, Cp minus అంటే specific heat at constant pressure, molar specific heat, minus at constant volume, specific heat. Okay, Cp minus Cv is equal to R for all gases. Please make a note. And Cp is greater than Cv. ఇప్పుడు మీరు జాగ్రత్త అబ్జర్వ్ చేస్తే Cp minus Cv R వచ్చింది. Now we'll try to divide and get another equation. We'll divide these two. Cp by Cv is equal to F by 2 plus 1 into R by F by 2 into R. R gets cancelled. R gets cancelled. Now what is left over? Cp by Cv is equal to పైన ఉంది, టేక్ LCM. 2 LCM ఇక్కడ LCM తీసుకోండి. ఓకేనా? తీసుకుంటే F plus 2 by 2 by కిందన F by 2. 2 gets cancelled and this becomes 1 plus 2 by F. But we know what is Cp by Cv? Gamma, ratio of specific heats. So as we know, Cp by Cv is equal to gamma, therefore this is equal to 1 plus 2 by F. Very very important derivation this one. So gamma is equal to 1 plus 2 by F. Here F is degree of freedom and gamma is ratio of specific heat of gas, that is Cp by Cv. Please note down, these are very very important things in the regarding examination point of view. Very very important, please. Write down please. See here. Now I got a relation between degree of freedom and gamma. Gamma ki degree of freedom ko relation vachindi naaku entadi. See, gamma is equal to 1 plus 2 by F. Now we will try to write on normal condition low mono, dia, polyatomic gases values kadadam. For example, mono value anta 3, diatomic gas and the normal condition 5, polyatomic and the normal condition 6. So we will try to find the values of gamma. So gamma for mono 1 plus 2 by, what is the value of F? 3. 3 1 is 3 plus 2, 5 by 3. So this is the gamma value for monoatomic gas, normal condition. Vibration, high vibration appudu 2 add cheyali, appudu 5 F place lo 5 pettali. Now gamma for diatomic gas enta avutundi? 1 plus 2 by 5. So 5 plus 2 7, that is 7 by 5. Okay, so that is the value for what? Diatomic gas. The same way for polyatomic gas, gamma poly 1 plus 2 by F value enta 6. 6 plus 2 8 by 6. So these are the values for gamma, monoatomic gases, diatomic gases and polyatomic gases. Clear? So like this you can do some numericals. Now let us go to another thing, that is first law of thermodynamics. Very very important in the examination. First law of thermodynamics. Clear? So next one ఏంటి మంది? 0తో అలాగే చెప్పేస్తున్నాం కాబట్టి now it is first law. First law of thermodynamics. So what does first law states? dq is equal to, you can write in two forms. dq is equal to du plus dw, or dq is equal to dw plus du. Both are right. So according to first law of thermodynamics, okay, what it is telling? The amount of heat given to the system, okay, is equal to increase in the internal energy plus external work done on that system. Okay, so dq is equal to du plus dw, like the dq is equal to dw plus du. That means external work done on whatever gas, it increases the internal energy. That is the first law. First law of thermodynamics and enti, the amount of heat given to the system is equal to total sum of increase in the internal energy to that of external work done. But here one thing you have to make in mind, the sign convention. Sign convention for work. Sign convention ఎలా తీసుకోవాలి? For example, you see, if volume is expanding, volume expand అవుతుంది. So when volume is expanding, then work is taken as positive. Okay, work is taken as positive. If volume is not expanding, let the decreasing. If volume is decreasing, suppose if volume is decreasing, not expanding, అప్పుడు ఏమవుతుంది? then you have to take work done is taken as negative. అదొక పాయింట్ ఇక్కడ. అంటే కంప్రెషన్ జరుగుతుంది. On the gas it is compressed by piston. When it is compressed, what happened? Volume is decreasing. Then work is doing on the gas. Work is done on the gas. This work done by the gas. This work done by the gas. Positive work is doing. అంటే piston తో మనం ఏం చేస్తున్నాం? గ్యాస్ని కంప్రెస్ చేస్తున్నాం. చేసినప్పుడు ఏమవుతుంది? వాల్యూమ్ is decreasing. So work done is taken as negative. When gas is moving, expanding, then it is taken as positive. These two are very, very important conventional signs while doing numerical problems, either graph problems or normal problems. Please note down. Okay, clear? Now let us try to understand the first law by doing some numericals. And yes, we know what is work done. Force into displacement, or pressure is equal to force by area. Let the P into A is equal to force. Put it here. dW is equal to in the place of PA dx. What is A dx? Volume. Therefore dW is equal to PdV. So in future in this chapter, whenever work done is taken, we will take this formula. dW is equal to PdV. Pressure and volume. dV is change in volume, P is pressure. Okay? So suppose if pressure is constant, then if you integrate it, PdV, you will get the work done. Or area under the curve. Work done ఎలా వస్తుంది? Area under the curve. For example, ఇలా మీకు గ్రాఫ్ ఇచ్చారండి. ప్రెజరు వాల్యూము. ఓకేనా? ఏదో ఎలా వచ్చింది గ్రాఫ్ ఫర్ ఎగ్జాంపుల్. దెన్ లైక్ దిస్ యూ విల్ టేక్ దిస్ ఏరియా. సో ఏరియా ఆఫ్ దిస్ కర్వ్ ఈజ్ నథింగ్ బట్ వర్క్ డన్. ఓకే, ఈ కర్వ్ అండర్ ఏదైతే ఉందో ఏరియా, దిస్ ఏరియా ఇస్ నథింగ్ బట్ వర్క్ డన్. ఇంటిగ్రల్ dW PdV from V1 to V2, or simply area of the curve, under the curve area, that is work done. Okay, so like that we can solve some numericals. Let us do one problem here for better understanding. And not only that, one more sign convention is there, that is cyclic process. Cyclic process. And for example, clockwise is taken as positive work, anti-clockwise is taken as negative, anti-clockwise. In cyclic process లో అంటే ఒకవైపు వెళ్తున్నప్పుడు ఇది క్లాక్ వైజ్ ఏమో పాజిటివ్, యాంటీ క్లాక్ వైజ్ ఏమో నెగిటివ్. దానికోసం మీకు ఒక ప్రాబ్లం చేసి చూపిస్తాను ఇప్పుడు. దెన్ యూ కెన్ అండర్స్టాండ్ ఇన్ బెటర్ మేనర్. I'll give one small numerical so that you can understand in a better manner. See here, I am giving you one problem. One graph problem will do. For example, this is a graph problem. Here xy axis is given, and he has given a problem, pressure versus volume. Pressure versus volume. Not only that, he has given a small circle. Okay, and he has given values as on y-axis P0, 3P0, P0, 3P0, and this one is V0, x-axis 3V0. And you can see the process cyclist is in this fashion. It is going. It is going in anti-clockwise. So anti-clockwise ఏం తీసుకోవాలి? నెగిటివ్ తీసుకోవాలి. ఓకే, యాంటీ-క్లాక్వైజ్ డైరెక్షన్లో ఏం తీసుకోవాలి? నెగిటివ్, బికాజ్ క్లాక్వైజ్ ఇందాక చెప్పాను మీకు సైన్ కన్వెన్షన్లో. నౌ హీ ఈజ్ ఆస్కింగ్ యూ calculate the work done in cyclic process. Calculate the work done in cyclic process. వర్క్ అంటే ఏంటి? ఇప్పుడు చెప్పాను కదా, ఇంటిగ్రల్ PdV లేదా ఏరియా ఆఫ్ దిస్ సర్కిల్. ఇంటిగ్రల్ PdV or area of this circle. This area. If you calculate this area of this circle, you will get the work done. What is work done? Integral PdV V1 to V2. Let the area of the curve. How to get the area? What is area of the circle? Area of the circle is pi r square. So area of this circle is equal to pi 22 by 7 into radius. See here, very important thing, which radius will take. For example, if you take this is the diameter. So what is the diameter here? 3p minus p. P0. 3p0 అంటే 2p0 ఇది. If you take this diameter, this is 2p0. అప్పుడు ఇది ఎంత అవుతుంది? p0, p0 radius. And if you take this one is the diameter, what is the diameter here? 3v0 minus v0 ఎంత అవుతుంది? 2v0. సో ఇటువైపు తీసుకుంటే ఈ రేడియస్ ఎంత అవుతుంది? v0, v0. సో అప్పుడు మనం ఏం చేయాలంటే యూ కెన్ టేక్ either this radius or this radius because both are equal to diameter. So pi r square లో r square కదా, r into r, what I'll do is area of the circle is equal to 22 by 7. 1 r I'll take this one and 1 r I'll take this one. ఒకటేమో పైది, ఇంకోటేమో x axis తీసుకోండి v0. And it is anti-clockwise, cyclic. So you can see it is going like this. So anti-clockwise notation into minus. So minus. So what is the area of the curve? Minus 22 by 7 P0 V0. Clear? See, these type of work done problems in cyclic process, we have to compulsorily follow the sign convention. Sign convention is very, very important. Clockwise take positive, anti-clockwise you take negative, and thereby you can solve the problem. Either integral PdV V1 to V2, లేదా area of the curve, you can get the problems. Okay, so like this you have to solve the numericals, and I think one more is left over. We'll see what is meant by isobaric process. After this one I'll go to that one. Okay, so have you noted down this problem? Very, very important in the examination also they're asking. Let us see the next one. See here, after doing the learning about the first law of thermodynamics, sign convention, so if volume is expanding, work done is positive, volume decreasing, work done is negative, cyclic process in clockwise positive, anti-clockwise taken as negative. Now observe carefully. Let us see what is isobaric process. Isobaric process. Isobaric process అంటే ఏంటని చూద్దాం. See, isobaric process లో pressure is constant here. In isobaric, P is constant, pressure is maintained constant. We know from ideal gas equation. What is ideal gas equation? PV is equal to nRT, number of moles, gas constant, absolute temperature. So isobaric process లో ఎవరు constant? Pressure is maintained constant. Pressure constant అంటే ఏమవుతుంది అప్పుడు? V is directly proportional to T because N is again moles, R is again constant. So V proportional to R అంటే V proportional to T అంటే ఎవరు? చార్లెస్ లా. Isobaric process లో V proportional to T means what? V by T is equal to constant. లేదా V1 by T1 is equal to V2 by T2 is equal to constant. And this is nothing but Charles' law. At constant pressure, the volume of a given mass of gas is directly proportional to absolute temperature, given by the scientist Charles. So isobaric process లో pressure constant అంటే V proportional to T. Okay, it is nothing but Charles' law. So let us see some graph. So in graph, if you observe, I'll draw 3 graphs for you. Okay, 3 graphs regarding pressure, volume, And next one, volume. Next one is volume temperature. This is origin. So first graph, if you observe, pressure is on y-axis, volume on x-axis. So here pressure is constant. Pressure is constant. So since pressure is constant, you can see pressure is constant. Okay? Pressure is constant. But volume is directly proportional. If temperature changes, volume also changes. If temperature decreases, volume also decreases. So the graph will be like this. P versus volume. Okay, na? Now let us go to the next one, V versus T. Because volume is directly proportional kabatti, straight line passing through the horizon. V proportional T, T changes, V changes, T decreases, V decreases. So it is straight line. Volume versus temperature, absolute temperature. Pressure versus volume, you can take small line. Okay? So like this you can take the graph for isobaric process, and these will be asked in the examination regarding Charles' law. Okay? Now what we will do is before going to the next topic in this, that is isothermal process or Boyle's law. Isothermal process or Boyle's law. Okay? We will divide thermodynamics into two parts. That is, now what all I have told you in this one before, starting from 0th law, this will be taken as part 1. This will be taken as part 1. ఇప్పుడు వరకు చెప్పిందంతా కూడా పార్ట్ 1 గా తీసుకుంది థర్మోడైనమిక్స్. ఈ నెక్స్ట్ పార్ట్ 2 థర్మోడైనమిక్స్ we will complete the chapter with followed by isothermal expansion or isothermal process, adiabatic expansion derivation, adiabatic process, okay, and some mathematical equations, and also thereby we have some more also like Carnot's heat engine, alage second law of thermodynamics. Okay, all these will be dealt in the part 2 and then we'll end up the chapter. So part 1, please note down all these things. Till now I think you understood all the things in part 1. Okay, so part 2 లో నేను ఏం చేస్తానంటే ఈ మిగతావన్నీ కూడా డిస్కస్ చేద్దాం. ఓకేనా? రైట్.